In this video, we're going to discuss the difference between sampling risk and non-sampling risk. So both of these have to do with the auditor making an incorrect decision. But sampling risk has to do with the sample not being representative of the population from which it's drawn. So let me give you an example. Let's say that you're looking at accounts receivable, and here's our population. This is all the different accounts receivable accounts, but then we just draw a sample. We just draw a sample of the account receivable accounts, and we're trying to see if they've been overstated. Okay, so if we look at this and this sample is not representative of the entire population, as the auditor, we can make the wrong decision. And there are a couple different types of that. So we've got a type 1 error is the risk of incorrect rejection. What that is that you look at this and you say, okay, I think, based on this sample, all the accounts receivable is overstated. But what if it was just this particular sliver that was overstated? And in fact, if you were to see the entire population, you would decide that, yeah, actually, in fact, accounts receivable are not overstated. So that's an example of type 1 error. So when we're dealing with controls, you're saying that the control is not effective, when in fact, if you could see the entire population, you would decide, no, in fact, the controls are fine. And then when we come to substantive testing, like, for example, accounts receivable, the balance of that, you're concluding that it's materially misstated when it in fact is not. So you're rejecting when in fact you should be saying, oh, everything is fine, but you're inferring that there's a problem. So that's a type 1 error. And a type 2 error is the opposite. Type 2 error is you're saying, oh, the controls are effective when in fact they're not. Or you're looking at the balance and saying, oh, the accounts receivable balance isn't overstated at all. Everything is fine. When in fact, if you were to see the entire population, you would draw a different conclusion as the auditor and say, no, in fact, it is overstated. Okay, so that's the difference between type 1 and type 2 errors. Now, non-sampling risk has nothing to do with the sampling process, and it really is just come down to the auditor makes some kind of mistake. So the auditor is drawing, so with sampling risk, remember, we're drawing the wrong conclusion because the sample's not representative. With non-sampling, you're drawing the wrong conclusion for some other reason. Maybe the auditor used the wrong audit procedure. It's also possible the auditor just calculated some numbers incorrectly. Okay, maybe, a lot of this is done with a spreadsheet, but sometimes people, even in the spreadsheet, they make a mistake with a formula. And so if you have some kind of error, and you end up concluding, oh, this is overstated or it's not overstated, and it's just that somebody made a mistake with the formula in the spreadsheet. Okay? Or if they have the appropriate evidence and they just don't know how to interpret it. So there could be any number of reasons where the auditor makes a mistake and it doesn't have anything to do with the sampling at all, but the auditor ends up having the wrong conclusion drawn. Okay? So we've got sampling risk and non-sampling risk. Now, sampling risk, you can actually quantify it. Okay, using probability and so forth, you can understand what your sampling risk is. But non-sampling risk, due to its nature, you can't have any idea of how many calculation errors are going to be made or whether people are going to interpret evidence correctly or not. So you can't quantify non-sampling risk in the way that you can with sampling risk. And sampling risk can also be controlled by making sure, again, using probability and so forth, that you have the appropriate sample size. Okay, so for example, if we're talking about, okay, the issue with sampling risk is we're having a non-representative sample. Well, what if our sample is non-representative because we didn't have a large enough sample size? What if we had a larger sample size? We might have ended up making the correct decision.